All right, let's get started. My name is Simon Shadler, and this is a presentation for my Design Visualization 3 class about adaptive solar facade and building design. So, just loading into the Revit file, this is the kind of output we are going for. This, as you can see, is the end result of an adaptive solar design facade based off of a building structure that we get from solar map data. And you can see here even where we would want our park to be. So we do this with numerous programs, numerous plugins. The download process can really be a hassle, but if you're patient with it, it's a really cool outcome. You get a lot of really cool results. This is only one of very many. So let's just first jump into what is adaptive solar design. It's the creation of massing forms, building facades, and sites using solar maps and weather data. And by using these solar maps and weather data, we can get cooler or hotter areas depending on surrounding buildings and just location that you enter in. For this example, we will be using the Lunken Airport at Cincinnati, Ohio. And by doing this, we can be very sustainable in our designing, and we can predict light patterns, and we can make buildings for any sort of environment. It's really cool because with the scripts that we write, we can move buildings around, and it will live update change, and it's all very efficient workflow. And we really want to get into this because of how it can benefit architects, lighting designers, and engineering firms for sustainability and lighting reasons. It's a really great way to gather information as well if you're just providing a case study for urban planning or something like that. So in this process, we'll be using a few plugins. For Revit, we're going to be using Rhino in Revit, which allows us to use Grasshopper in Revit, as well as the program Rhino. And thus, with all of these wonderful 3D modeling programs, we can use Grasshopper, Dynamo, Revit, Rhino, and we can use plugins in Grasshopper such as Ladybug. And I also downloaded a MeshTools plugin. There's a lot of downloads, so bear with me. Here's some related projects. This is facades that adapt, and it's really cool with these projects. They use solar panels too that kind of react to the incident sun ray. Here's a general process that I just kind of explained, so we'll get into it. We'll do a full in-depth after this, but this is some masses I made in Rhino, just random kind of building masses around a public square that has not been built on yet. And here's a script, and now we have it in Revit. Using a Dynamo script found on the Autodesk Generative Design forums, this one creates building shapes based off of surrounding context and solar placement, and this is where you put in all your input layouts. We'll go into that later. And then from this script, we can create a study. And what's really cool about studies is that you can get hundreds or even thousands of options if you have the time, and you can sort them by what you're looking for. So we have height, plan areas, open space, and all this stuff. And in the end, I ended up choosing this, and we'll dive into that later. You can then bring your Revit model into Rhino using this command. This is my solar data chart, all Ladybug stuff. Well, not all, but primary Ladybug stuff. And you can see here, this gets us an incident radiation, this gets us a sky dome, and this gets us a sun path. Here we can generate our facade based off that sun path. And here's kind of what they both look like. So what's really cool that I didn't mention is that they load into both programs. So it looks a little better in Rhino, but we can always, that's further editing. Here's the full script. And here's some references. So in part 2 of this video, I will dive into the programs and kind of the workflow. Cool, and like that, we are back with part 2, because I can only record 5-minute videos. But yeah, definitely check out these references if you need to learn anything along the way. Here's some good downloads, and yeah, so all these YouTube videos were very, very helpful. Let's jump into Revit, 2022 to be exact. I think that's what you need to do for this, just to make the Dynamo case studies work. I was having a problem with that earlier. So kind of my first step was I did not make these maskings in Revit, but let's be clear, you absolutely could. Just trying to show the ways that we can kind of work. So I'm going to load in my Rhino in Revit. Here's my Grasshopper script that nicely loaded in with it, and let's get this guy go. So yeah, this is kind of what I'm talking about. If you have these Rhino models like I do, if I select this, these are these guys. So this is surrounding context, and this will take it into Revit. These are like the new Revit commands in Grasshopper, which is really cool. This geometry we will also use later on as context for our incident radiation. So the first step for me was I'm trying to go back and forth as much as possible. So Rhino, I got into Revit. Let's get out of that for now. So now we're going to go in, and I already have Dynamo running just for the sake of time, and this is what I got to download offline that kind of creates these building models that we see here. So I did all my I entered in all my information, latitude, longitude, and that's for Cincinnati, and you can just fill in all these inputs, and eventually you can run a study, and you do that by just going up here and clicking create study. I'll pop that guy up right now. So by doing my study, I got a bunch of options. As you can see here, you can sort the buildings by their solar area, you can sort them by their open space, and except this one is not. I think it's because I have a filter on. But now sorted by the most open space, so that was by the least open space. And we can even go here and we can like take chunks of which ones we want, yada yada. So it's really cool. We got a bunch of different designs. I opened them in Dynamo, and once I opened in Dynamo, I was able to bake it back into Revit. And when I bake it into Revit, it's a solid, so it's not this facade. I do have it hidden, so if I hit reveal hidden, you'll see this is the kind of model I brought back in. I saved it as a hardscape just to give it a unique element. So now we're going to go back into our Rhino, and I wish Grasshopper would just stay like that. I guess that's fine. Okay. And now we're going to do some solar mapping. So this is a link file to load an EPW weather file for I'm using Lunken Airport, Cincinnati, Ohio, as mentioned. And from this we can get a bunch of cool data, but really we're just interested in location, direct normal rad, and diffuse and horizontal rad. And we plug that into here, which gives us a sky matrix. And the sky matrix is basically what gives us all of our data. So if I set this to true, then it will run the program. We're going to keep it false to keep it normal. This alters north, and this is just a quick little like thing for hours of the year, and that's just important for getting the data accurate. You can find that in the YouTube videos reference. These two aren't as important, but that's the sky dome and that's the sun map, so really cool little data you can use there. This is what we want because that's how we get the building property. I do have the mass hidden, by the way, but you can kind of get the point. So after all that, we go through all this, we explode the faces so that we can create panels. We scale the panels as you see here, and then we can bake into Rhino, or if we click this, we bake into Revit, which is as you can see here. So the next step is baking into Revit, and pretty much that's how you get your facade. You can run this in Enscape or whatever, but it's really cool that you have the option to do a bunch of different building and park patterns. I'm about to run out of time, so I'll just cut it super short. But thank you for watching, and contact me if you have any questions.